All right, Julie, the stage is yours. Thank you.
Awesome. Thanks, Pranav, for the intro. Um, yeah, everyone can see my screen. Okay, awesome. So like Pranav mentioned, I'm going to be talking about software engineering fundamentals. So what does this even mean? Right, good machine learning code and good deep learning code. There's just general good practices for how you like set things up with your environment, how you control different versions of your files using Git, and how you write really nice looking code with Python. Great. So by the end of this lecture, learning objectives are to understand how to write code according to proper Python programming style conventions. We're going to talk about how to use Conda as a package manager and best practices for doing so, as well as best practices for version control using Git. As you can see, that's what we have reflected in our outline. We're going to go over some tips for good programming style in Python, how to use Conda as package manager, how to use Git as version control, and also how to set up GitHub for sharing and collaborating. So first, let's talk about Python programming style. So why do we even bother with trying to write code in good style? First, it's easier for you, collaborators, and future collaborators to read, understand, and debug your code. Secondly, writing in good style helps us to write code that is more robust against bugs. And the goal is to write really modular code to avoid repeating yourself, avoid writing like chunks of code that repeat over and over. Also makes your code easier to maintain. So you like slightly modify if you just copy all your code. If you have many copies of the same code, so you want to make some changes. It's pretty easy to like make some changes in certain spots and not make some changes elsewhere. And that just really makes your code very error prone or bug prone. So one area in which I feel like I myself struggle with, and I'm sure is a common pitfall, is the idea of organizing your code into modules in Python. So in Python, I'm sure everyone's seen like how you can import different packages. So like I'm sure you've all seen like import numpy as MP, import math. So modules are essentially files where some other developers have written functions, and those functions are publicly shared and you can download them through like a package manager like Conda, which we'll talk about later. But what I didn't know going into the bootcamp and about Python is that you should also organize your own functions and the own functions that you write into modules. So you can do that by, you really just want to avoid having like one large function, one single file, one single .py file with all your code in it. So like the separate logical separations of your functions, you want to separate out into modules. And then you can import them into like a main function, a main file. So what I have here is like an example. So I have this like main function or this main notebook, and I'm importing both the third-party math package. So this is like, you can look it up online, you can look up math, and it has a lot of like basic math functionality. And then I also have like my custom mymath function or mymath module. And I use the as operator to avoid the namespace collision here. And I'm importing from demo module. So as you can see here, this is the file system, the directory tree. So I have my demo module, and I have, you have to initialize it within an init.py file. That tells Python that demo module is a package and that it should go look in there for modules potentially. So this first line up here, it's telling Python to go into demo module, which is in your current working directory, import this module math.py, and to call it mymath. As you can see in the next cell, basically we're able to use your like custom function from your own module. and that performs some sort of arithmetic operation. And we can also separately just use the publicly third-party math module and use like a log function there. So yeah, best practices for importing modules. As you saw in the example, we can use as to rename modules, avoid namespace collisions. We should in general only import the modules you need. You should avoid just importing everything from a module. You just lose control over exactly what you import. This can cause some naming collisions. It can also cause security issues. So be really diligent and only import the modules that you need. I think another common mistake that I'm like extremely guilty of, at least initially, is the temptation to use global variables. I think it's very convenient, especially when you're like first starting or like making an initial like draft of code. It's very easy to, it's sometimes very convenient to use global variables. However, as you like continue, this is an easy source of bugs. Perhaps you have like global variables set somewhere and modified somewhere else, and it's really hard to keep track of how those changes are made throughout the program. Also worth noting that sometimes it can produce like interesting behaviors, like because of how global variables are set at import. Perhaps if you import elsewhere, if you also import like global variables from a module like multiple times, there's like can be unexpected behavior there. I think most importantly, it's just very hard to track sometimes. If you have a global variable, it's getting modified in different functions or modified throughout your code. It's hard to keep track. Instead, what I recommend is if you need to use constants, you can use module level constants, and you can also use config files to organize your other like constant like variables. So like I know when I first started like setting up models, sometimes I would just like have all of these like parameters just like listed out in like a notebook. But what you really want to do is you want to organize those away into JSON files or into like .yaml files. And this allows you to very clearly and very easily and cleanly pick which configuration you want instead of manually going through and like changing all these different parameters in your model. So this on the left is a .json file from like gradient boosted tree model. And then this is an example I pulled off online for our CNN. This is a .yaml config file. Alternatively, you should try your best to abstract away constants as parameters and functions or as attributes of a class. So on the left, on the top and the bottom is the global variable approach, and the bottom is the more modular approach. So you can pass it in to a function, and the function can change it or access it. And that just allows you a greater degree of control, the same for a class, as you can see on the right. Okay, another thing that's important to keep in mind with Python is Python is especially particular about indentation. So this might be different than like some other languages like C or C++. In Python, indentation is how the interpreter knows where code like falls in logically. So if something is indented, it is all part of the same like logical block. And that can really actually change the semantic meaning of your code if you're not careful about your indentation. So for example, in the top, like if you have the print statement within the while, then it is executed 5 times essentially, because it's evaluated inside the while statement. Otherwise, if you're not careful and you move it outside, it really functionally changes what the code does. Other interesting things with Python, this is like also relatively new. I think there's the idea of string formatting using f strings. I think it's quite nice, and wanted to go over it. So essentially on the top, you previously had to use this percentage notation for how you format strings with variables. And now it's actually quite nice. Any sort of variable really, you can very easily like just format it into your string using curly brackets. So strongly recommend. I think this looks cleaner and is also actually, it runs faster because the strings are evaluated at compile time, at runtime. Another cool thing about Python that I learned as I went through the bootcamp is that you can write code or write functions with default parameters, and this just gives you a little more flexibility for slight differences in how you want to call your function. Or perhaps you have like lots of settings or lots of parameters, and sometimes there's like very commonly a default like configuration, and only rarely do you actually need to change things. So this can make it a little bit more convenient when you call that function. Also, so you can just specify, if I don't pass in an argument in that position, B will basically be none. So I could call foo with either 1 or 2 arguments potentially. Also be careful that the default parameters are set when the module is loaded and not when the module is called. So for example, if I like set B to be like time.now or time.time, that'll be when the module is loaded and not perhaps like you might intuitively think when the function is called. So just be cognizant of that. Another thing about Python, commenting is a little different. Every language I think has like its own conventions for commenting how you document your code. So in Python, there are essentially 3 types of comments, doc strings, as well as inline comments and block comments. The doc strings, I feel like doc strings are like the way you document what your modules do, what your functions do, and what your classes do. So this is where you like annotate it with general, like a brief description, and then also more detailed like description of what the function does, or like the arguments it takes in. So this is an example of what a doc string might look like for a module, as well as what doc strings would look like for classes or functions. So on the left is for a class, there's like a brief description, and then also you annotate each method within the class. For functions, generally it's nice to specify the arguments, as well as the return types and potentially like exceptions or what sort of errors might be raised. Besides doc strings are kind of describing, you can think of it as serving as documentation for your modules and functions and classes. The other types of comments are generally to explain complicated code that would require an explanation to understand. And so you have inline comments. So these are like very short. Maybe you have like kind of a tricky line of code that's maybe the notation makes it tricky to understand or something. And that would just follow your code. You really just want to keep that to a single line. The other type of comment is a block comment. So that's like on top, and it explains the code below. So if you think you might need a little bit more room to explain, I would use block comment as opposed to inline comment. Other nice thing to know about Python is typing. I think typing is relatively new, but it just allows you to annotate your methods with the input and output types essentially. So as you can see in this example, there's basically in this class method essentially, it takes first var can essentially be a type int. It accepts type int. Second var can be type foo. Foo is likely an alias, so you can kind of define your own classes, your own types as well. And then it maps to an int. So we also get the return type. And this is really nice. You should try to generally annotate your public methods or anything that's going to be exported. And it's like a form of documentation, and also helps other people to know how to use your functions and your methods correctly. Especially good if you think your methods are vulnerable to type-related errors. So yeah, you have like your standard typing for like int, string. You can also make your own types. So there's like generics and type var. So these basically potentially like your list, you want to be flexible to your list having, sometimes your list will consist of all integers, sometimes it will consist of all strings. And sometimes, so I just like create a type var of like my custom like underscore t type. And then I basically say this function can accept like a list of this type var, and it maps to the same one. So I guess this is a form of kind of an abstraction of creating something generic that's also somewhat constrained. We can also constrain it. Sometimes we can constrain, we don't want to make it completely generic and constrain it to like a subset of types. Yeah, definitely read through the documentation for more detailed guidelines, but that's a generalized overview. Yeah, so now I want to talk about Conda as package management. So what is package management? I feel like when I first started programming, I kind of just, I didn't have a really good understanding of what package management or like why we want to use Conda as opposed to pip. So package management is the idea that different packages have different dependencies and we want something to help us organize those and resolve those dependencies. Also, virtual environments. Conda, unlike pip, offers virtual environments, so you can install different versions of packages for your different projects to fulfill the requirements for that project. So why should we use Conda opposed to pip? What are like some of the differences? So pip is basically just much more minimalistic. It also has a lot more packages. So Conda supports dependencies that are not Python. It also has like a smoother installation because pip builds the package as it installs it for you. So there's always a chance that your compilers or your libraries are not in some way compatible with the package. So there's a chance of failure there. Like I previously mentioned, pip has more packages than Conda. Conda has more thorough dependency management. So it performs like a satisfiability test, and that tries to make sure that all the dependencies between packages are concurrently satisfied. And like I mentioned previously, Conda offers management of virtual environments built in with the package management system. So I would say like pip is a lot more basic. It's a lot more lightweight, but I think for your projects, I would recommend using Conda. Also, like it's very nice to have the virtual environment system and be able to separate how you manage packages for your different projects. So next, we're gonna do a live coding demo, and I'm gonna talk through how we can set up a virtual environment using Conda. Okay. So I have a GitHub repo, which I'll share at the end of my lecture, because I think as part of my demo, I'm going to also be setting up the GitHub repo. But I will share that with everyone at the end, and you can see the commands that I'm running as we go then. Okay, so what we want to do is, what you'll want to do initially to get started is you'll need to essentially download Conda. You can download it through Anaconda or through Miniconda. I would recommend using Miniconda. It's more lightweight, but both work. So what we're going to do now is we're going to create a new environment, and then I'll show you how we can manually install some packages. And then we're also going to use a configuration.yaml file to export our environment, and then create a new environment using that YAML file. So let's start by creating a new environment. So that's Conda create-n, and then we can name our new environment like demo. And so let's going to create our new environment here. Okay. Now we need to activate the environment. So basically that means that like if we're in this base environment, we can take a look at what environments we have using Conda, sorry, info --ems. So we have base, which is what we're currently in, and then we also have demo. So basically, if you're like having many projects with different virtual environments, you just want to be careful, like you're activating the right one for the right project. So now let's activate our newly created demo environment. Now you can see we're in the demo environment, not the base environment. So you can install packages like manually, like one by one, and I can show you guys how to do that. So we're going to install like tqdm, and then the -c means for channel. So that means that by default, Conda will look in a default channel. Channels are essentially where Conda looks for packages. But there are also other channels, so like Conda Forge, Anaconda. And so when you're installing packages through Conda manually, you have to kind of, you like have to look online and see like which channel it's recommended you install from. Otherwise, sometimes the package installer might have difficulty finding it. So we're going to install this package manually. While that runs, yeah, that should finish installing. So it will also install the dependencies, required dependencies for that package. You can see, should be done in just a sec. Okay, great. And what you can do is you can also take a look at what the packages, what packages we have and what versions they're all in using Conda list. Great. So you can see like I have all these packages. I can see their version number, I can see their build, and I can also see which channel I got them from. So that's great. So now that we have this environment set up with some initial packages that we installed, set up manually, we can export this in a .yaml file. And the beauty of this is that, say you write this project and you use this environment, use a certain environment to do it. As you might imagine, packages get updated, people make changes to them over time. And so there's the possibility that some of the functions or the functions or methods that you relied on from your packages might be changed. So you'd want people trying to replicate your code to be able to know exactly which version of everything you used. And so that would allow them to also recreate your virtual environment and basically run your code properly. So one way you can do that is you can share, you can basically share the configuration of your virtual environment in a .yaml file. So how we're going to do that is conda and export. And then we're going to export it into an environment.yaml file. Awesome. And so we can open that up and take a look at what it looks like. So basically it has like the name of our virtual environment, the channels that we use to go look for our packages, and then basically all of our dependencies. And so using this environment.yaml file, we can actually recreate an environment with these exact same dependencies. So that's actually what we're going to do next. So we're going to deactivate this current one. And we're going to create a new environment from this .yaml file. And we're going to see that it's like exactly the same. So in this case, we're using like a .yaml file that we ourselves generated. Normally, you might try to do this from like a GitHub repo that you're cloning. You would also try to, sometimes we'll have a .yaml file, sometimes we'll have a requirements.txt file. Pretty similar. The txt file is usually generated through pip, but usually you can also use that to try to create your virtual environment through Conda. So now we're back in our base. So now we can try creating from file. So that's going to be conda and create, and then the -f is for from file. So we're creating it from our environment.yaml file, and we're just going to rename it something else because normally if you just create it from a .yaml file, it will copy the name. So we're going to create this file, this environment. And so it's like, first it's going to find a place to put your environment, similar to what happened previously. Also worth noting, I mentioned this in the notes, when you're installing manually, you can also install the version number manually. So say for some reason the environment.yaml is like not super compatible with your system, and you just want to go through a list of packages and install them manually. You can specify version number basically. After you specify the package name, you can set equals like the major, minor patch number. So while that's running, we can talk about best practices for Conda. The Conda is quite good. It handles the dependencies. It also, like by default, unless you specify, it tries to get the most recent compatible versions with your system. And I guess best practices, it's quite nice to share your .yaml file. Also, it's nice to try to use other people's .yaml files when you're trying to run their code that they might share. However, keep in mind that although this is like much better and much easier than going through like the list one by one and manually installing them, sometimes there can be difficulties porting across different operating systems. So while this is a great method, sometimes it's not always successful. So do keep that in mind. Let's take a look at our, okay. Great, so we have now created this environment, so we can activate it. So this is from our .yaml file. And we can take a look at what's in it. And as you can see, this is exactly the same as what was in our demo file. So we were able to recreate the environment using the .yaml file that we exported. Like I said, you can also do this when you're like starting off with other people's code, like from GitHub. Usually they'll also include a requirements file, and you can use that to take a look at how to set up the virtual environment, essentially. Okay, so we talked a little bit, we probably mentioned GitHub. So GitHub is how you share code. That is like a centralized way of how you share your code. But you also have a centralized way of how you locally also keep track of your changes, and that's known as version control. And you can do so using Git. So what is version control? I think people generally have a very like scattered understanding of Git. I know I certainly did. I feel like I always sometimes hear it used and sometimes try to use it, but at least for a while I had a hard time understanding what it really does and how to really use it effectively. So version control is just keeping track of different versions of your files. So nice analogy that probably most of you are familiar with is like Google Docs. So Google Docs is a form of version control, right? You make some edits, or other people who also have access to the doc are making edits, and you can keep track of changes. You can go back, you can see what was changed, see what was changed when. You have a record of all the changes. You can go back and revert actually to different versions, previous versions of your files. And so you can also do the same with your code, essentially. And you can, this is, as you can imagine, pretty desirable because, you know, you put a lot of work into writing your code. You want to be able to make sure that if you like make some changes that you don't want, you can go back, you can see what was changed. So there's a couple ways you can do this. There's kind of the naive approach, which is just to like create many copies of your file. I think this is perhaps a low barrier to get started because it's like the most simple, but it's also just like very painful later down the line to actually keep track of the versions. You make like copy 1, copy 2, and then you like make copies for each of your collaborators. It's really hard to keep track of what's being changed where. It's also hard to like, you probably aren't going to make a copy every time you make a functional change. You're probably going to have, it's just not very well organized, also not very efficient. There's also, if you're doing all your coding in a Jupyter notebook, which I don't recommend, I think you should use Jupyter notebooks for demos, but you should try to avoid like having all of your code in a Jupyter notebook. But there's some systems that like Jupyter Notebook that do a form of version control. You can like save checkpoints of your notebook, and you can use those checkpoints to go back and revert to like what your notebook looked like at a certain checkpoint. That's okay, but it doesn't allow you the greatest degree of control over how you're managing the different versions. A formal version control system like Git is actually really clean and also allows you like a really nice degree of control. You can have like a log of all the changes you make, and you can like do git if and like look at all the differences between files that are changed. And it allows you like a really great degree of control, I think, when managing different versions of your files. So what is Git and how does it work? I think Git is a little confusing because there's so many like levels to the versions of your files and how those are stored. So Git has this like these levels of where your files are stored, and also has like branching and how it keeps track of the different versions of your files. So I'll briefly go over like these like 4 like stages of like where your data is stored and transported back and forth. So you have your workspace, which is like where you make the changes most immediately and directly. So like you open up VS Code, you open up Vim or Emacs, and you like make a change that's in your workspace. And then you have your index, which is like an intermediate between your workspace and the local repository. So everything like the 3 stages, 3 leftmost stages are all kind of, you can think of them being local to your system. The workspace is most immediate. The local repository is, it's on your system, on your local system, but it's essentially like the centralized version of all your changes. And it's like, you can like be a little bit more messy in your workspace as you like experiment with things and you like try different things to see what works. And generally when you're like relatively happy with the change, then that's when you update your local repository with the change. So what's really nice is this basically allows you to have like levels of how happy you are with your code. So in your workspace, this allows you to like be really flexible with like the quality of code you write, or also like how well it works. You get to experiment and you can like break things a little bit. And then generally when you think you have something that works, you push it up like the hierarchy of your stages. So you can like push it to you add it to your index using git add. The index is kind of like an intermediate zone in between workspace and local repository. It's nice. You should always try to add and then commit, because potentially you add something by mistake. You like add something like a file you don't want to add, and this kind of lets you have like a flexibility in basically like taking it back before you commit it to your local repository. Because you can revert, but it's like a little bit more involved to have to try to reset after you commit. So at that point, you're happy with everything you've added to your index. The indexing is also nice because you might make some changes and you might be in the process of making like lots of different changes, and then one of those changes works and you want to add that change to your index, or you want to separate out your commits because they're like functionally different changes in your code. So you might add, like you want to add everything from this one change to your index, and then you commit that change. And then you want to commit with a nice commit message. We can talk more details later. And that basically now you've updated the local repository. And then you also have a remote repository. So remote is usually what is like shared between you and your team, shared between like collaborators. So local is on your system, remote is usually hosted somewhere else. Usually like a cloud-based service, could be GitHub, could be GitLab. There's a variety, you can choose from a variety of different services that host remote Git repos. So you can push basically the changes you make from your local, and you can update your remote basically. And then going the other direction, you can pull. So what pull does, or pull or fetch does, is say you make some changes and you're also working on some other changes you want to update. You want to update things so that way you have the most recent changes, or perhaps your partner made a change and you want to update your code to also reflect that change, so you can use their newly changed code for the next step of what you're going to work on. So you can use pull or rebase, and that basically brings the changes to your workspace. You can also use fetch, which moves it back to the local repository on your system. Also really nice about Git is that, like I mentioned, so you have these like levels of where your files are stored and transported back and forth. But you also have Git, the idea of it being like a branching version control system. So typically you'll have like a main branch or a master branch that is like the final version, or like the thing that you're happy with. And then you have your master branch, and you'll basically check out branches from that where you can do feature development or make some major, like make some changes. And that basically alleviates the risk of only having one master branch or one main branch, making changes that you're unhappy with and like having to constantly try to revert back. If you keep like one copy of what's working so far and you just don't touch it, and then you make changes through branches, that's a really nice and clean approach. And it also allows many people to work on it at the same time. So you can check out multiple branches for all the things you're working on. Your partner can also check out multiple branches. And then as you finish your change and you're happy with it, then you can merge it back into the main copy. So yeah, that's what checkout does. Checkout basically creates a new branch and allows you to go from there to make changes. Git diff is comparing. So you can compare basically files between two different branches, and that's quite nice because you can see exactly what's changed. So this here is like summarizes a lot of basic Git commands. We're going to actually go over pretty much all of these in the live coding demo, but I wanted to have them here for you to look at later at your own time. Also, I like walk through how to use each of these in the notes, so feel free to check those out later. So yeah, now we're going to switch over to live coding. So I have this in a notebook actually. So it's all compiled together, but normally you would run these commands in like terminal. You can also run them in a Jupyter notebook, but I think generally I would run them in terminal. It just allows you greater flexibility. So I opened up a Jupyter lab of basically this demo repository, and Git init is going to create a local Git. It's going to basically create a Git repository that reflects my current working directory. So let's do that. Okay, so we just, it basically tells you we initialized an empty Git repository. in this file, so it's in the .get of my current working directory. What you can do now is, I always like, as I'm working, I like to run 2 commands, which is git status and git branch. So git status basically tells you what are my uncommitted changes and where are they at. Also, git branch basically lets you check which branch you're on, which is good. So you want to be careful that you're not making changes to an unexpected branch. Okay, so see what happens when we run git status now. Basically, we're on this main branch, which is what is set up by default. And we have all these files that we basically haven't added to the Git repo yet because it's empty initially. So what we can do is we can add files to the index, like we saw in the presentation. So we added this file. If we run git status now, we can see that we have the untracked files. So these are like files where you made changes, but you haven't, it's just in your working directory. You haven't added them to your index and you haven't committed them. And then here, this is basically your index. This is the changes that you've added to your index, but you have not yet committed yet.
Julie, we have a question from the audience. Can you increase your font size? If that's possible, then that would be useful.
Oh, yes. Sorry.
Oh, thank you.
Is that better? Okay,
Perfect.
of course. So now we have like an environment.yaml file that's in our index and we want to commit it. And that's going to commit it to our local repository. So that's git commit and then -m for message. So you always want to commit your code with a useful commit message. So that's, you write a good commit message using a verb in the imperative. So that means you say add and not adding or added. And then you follow that with a short, like 1 sentence, describing, like giving context on the change that you made. So in this case, I add an environment.yaml file, and this has to say virtual environment config. So we see that we've made this commit, and if we check the status again, we see that we no longer have the environment.yaml file in our index. So now what we're going to do for the sake of time, normally what you would want to do is you'd want to actually, you'd want to add each file individually. And that's because you just really want to be cognizant of what you're adding and what change that reflects. But in this case, we want to like have everything update all our files. So we can just add all. And then our commit message, we add the remaining repository files for our demo. Great. Okay. And now what we're going to do next is we're going to check out a branch for like a slight development change. And we're going to see that you can basically, what branches allow you to do is you can concurrently have like 2 versions on your branches. So we're going to check out a branch. So that's git checkout-b branch. Usually you want to name it like you can have your branch, maybe like it's nice to include your name, especially if you're working with a team. Also briefly what sort of change you're working on or what feature you're planning on developing in the branch. So we've now created a new branch and we also switched to it. If we look at git branch, we can see all the branches that we've made, which is so far is just 2. We have the main branch and then we have this newly created branch. So what we're going to do now is we're going to make basically like a toy change. Originally A was 8, it's come to 12. We're going to change it to 2. Okay. And then we're going to save our file. And we're going to run git status. Take a look at what was changed. So it tells us that we modified this file. And we also modified the notebook, but that's because we're running the notebook right now. So now what we're going to do is we're going to add we're going to commit this change, add and commit this change. So that's demo.py. So we're going to add that to our index. And then we're going to commit this file. And we write a nice commit message for it. And so recall, we're still in our dev branch here. And so let's see what happens when we run demo.py. Remember, we made the change to change A to 2, and that reflects here. So what's really cool is we can go back to main. So we can switch branches. So we switch back to main branch. And if we run the version of demo.py in the main branch, we have what it was earlier. So really nice feature of Git is this branching mechanism. You can have concurrent, basically, versions. Concurrently, at the same time, you can have different versions of your files. It's great for when you're like developing something new. We haven't gone over all the commands that I talked about earlier when we were talking about Git, because we're going to, at this next step, we're going to basically set up the remote repository for our Git repo. So I mentioned previously that you have many options for hosting a remote repository. And for our demo, we're going to use GitHub. Briefly, I want to go over best practices for Git before we move on. So I think I've actually talked over most of this. If you want to write helpful commit messages, this is for yourself and also for collaborators, like I guess most of this lecture we've talked about. So if you don't write helpful commit messages, if you write something like fix every single time, it's going to be really hard for you to go back and look at your log of commits and see exactly what was changed or what feature was modified and what bug was fixed. So you want to use, you want to be as specific as possible and provide context for your change and use, like I said, a verb in the imperative followed by a short sentence after. Generally, you want to try to limit each commit to one functional change. So you don't want to make many, many changes and then have that all bunched together in one commit. This is nice because Git has certain features that allow you to revert back, or you can also like cherry pick commits. So I can choose which commits I potentially want to. You create a new branch and you like cherry pick different commits. That's really hard to do if you have like a whole lot of changes all like represented in a single commit. But if you have one change per commit, that really allows you to like basically handpick the sort of changes that you want to have in your new version. I think I also mentioned this before. Generally, recommended workflow is to check out branches for future development and then kind of preserve a master or a main branch. And when you're really satisfied with the change that you've made in your development branch, then you can merge back into the master branch. And a lot of the times you'll do that using like a hosting service like GitHub, because that allows like you have nice functionality in code review. We'll talk about that really soon. It's really not recommended that you do all your development in master branch because you basically are potentially breaking a currently working version of the file. So you can think of, you want to protect your master branch or your main branch because that's currently what's working. And as you're making these changes, as you're building new parts of code, you do that in development branches and you can burst in. You also want to generally avoid committing large files, like don't commit like notebook checkpoints or large unnecessary files. This is because over time, your Git operation performance can be degraded by having like very large files in your repo. So the next part of the demo that we're going to go over is involving the remote repository element of Git. So Git is a version control system, and it's not the same thing as GitHub. I think this is extremely confusing for me. I got really mixed up with this. The Git is the version control system, has the various stagings of where your files are stored and transported, and it lets you keep track of basically version control history, helps you manage different versions, and part of Git is the property that you host your repo also remotely. And there's a number of ways you can do that. And GitHub just happens to be one of the most widely used and popular ways of hosting remote Git repositories. GitHub is really nice. It has a really nice GUI. It also has nice functionality like code review. You can also basically set up like breaks, so that way you can protect your main branch from merging. You can require that there's code review through a pull request before people are allowed to merge into your main branch. So it has a lot of really nice functionality in that way. But GitHub is basically the remote repository element of Git, and it's one of the ways you can do it. So now what we're going to do is transition back over to our code, and we're going to set up the remote repository. So what I've already done beforehand is I've created a new repo on GitHub. So before you start working, you're going to have to create like a GitHub account. You're going to have to authenticate it. You can authenticate using SSH, like I've done. And you can like create a new repository. And that like generates a URL for you to use. So this is a URL that's associated with this repository on GitHub. And what we're going to do is we are now going to set up the remote repository for our Git repo. So let me make this a little bigger. So we have the URL of our GitHub repo, and then we're going to basically set up the remote repository. So we're going to go git remote, add origin. So add is adding a remote. Origin is kind of by convention. You usually call your remote repository origin. That's, I think, because like a lot of the times you'll be cloning from like GitHub or from a remote repository. And so that's like the origin of where you got your repo. But I think that's just like a convention thing. So we're going to add the remote. And then right now, let's take a look at what branch we're in, git status. So we switch back to our main branch, which is great. You can tell it like kind of helps you out, like how to set up your origin. And we want to push, let's push our main branch to GitHub, to our remote repository on GitHub. So right now locally we're on the main branch. And so git push is basically push the changes from my local branch to an upstream branch on this remote. And let's call that remote branch main also. So the -u is for set upstream branch to also be main. And if we run this, so this is the authentication part. So I'm using SSH, so I have like a SSH key. Okay. So basically it sets the remote branch main to the local branch main to track the remote branch main from our remote origin. If we refresh GitHub, we see that we basically pushed, we have one branch and that branch is called main because we specified it that way. And then this is like basically everything that was in our main branch of our local Git repository. Okay. So we have our main branch now pushed to GitHub. And we also have remember we had our other branch, we had our dev branch that we made the small change, demo change on. So let's switch over to that branch, and we'll also push that to a remote repository. So just a general note, you don't really want to merge changes locally. It's generally good practice to push the changes as branches, and then you can make the pull request on your like remote GUI, remote repository service like GitHub. That's also generally because you're just not allowed to. Normally a GitHub repo is set up so that your main branch is protected from merging without code review. So in this case, we don't have anything set up yet for that, but I'll show you how to do that in just a minute. So we switched over to our dev branch. Recall that this has the change to the demo.py file. And what we're going to do now is we're going to also push this to our remote repository. So we're going to use the same command as above, but instead of a remote branch called main, we're going to just call this the same as a local dev branch. So we're on the local branch dev demo change JSON80, and we're also going to set the upstream branch in our remote repository also to be this name. Okay, so this created a new remote branch called dev demo change, and you can see how it tracks between the local and the remote repositories. So as you can see, GitHub tells me that we just made a change. There's like a recent push to a remote branch, and what we can do now is hit compare and pull request. So that's going to compare the newly pushed branch with the base branch, which is our main. Create a pull request. And honestly, it's really nice in GitHub because you can look over here. If I had made multiple commits, you could see the different commits and like the commit log. And that's where you see all the messages that you write. And you can go to your files changed, and it basically gives you the diff. So originally it was 8, and I deleted that and I added 8 to instead. So it lets you see exactly which files are changed and what was changed. So now going here, I haven't set up anything to protect the branch from merging, so it requires no code review. So I can just merge this. And also GitHub does it really nicely. It actually like checks for conflicts before you merge. If there are conflicts, you usually have to go through and manually resolve them. So now we have our dev change, and we're going to merge that branch into our main. We hit merge pull request, confirm the merge. Great. And if we look over in our code, in our main branch, we're in our main branch right now, and we can see that we have this commit that came from the dev branch in demo.py. We can open it up, and we can see that it has the most recent commit from our dev branch. Okay. That's great. So we kind of talked through how you can create new branches for feature development. You work on those locally, and you also push those remotely. And then within like GitHub, you can compare and do a pull request. And normally that pull request was kind of unnecessary because there's nothing really, we don't require code review yet in this repo. So I'm also going to show you guys how you can set up rules to basically prevent merging without review. So we go over to settings, we can go to branches, we can add a branch protection rule. So generally you want to protect your main branch or your master branch. And then you can require a pull request before merging, can require approvals, review from code owners. And then I guess let's also include administrators so that way it shows. So we can create this rule. Great. So we've now created this rule. We can edit it, we can delete it later. Looks great. So now what we can do is we can try to make another change. We can try to push it, and you'll see that when we try to make the pull request, it requires a code review. So let's do that really quick. Let's check out a new branch. Let's modify our demo.py again. We can change this time. Let's change b to be equal to 10. Let's check that change. Let's now add the changed file to our index and commit it. So that's here. Now we're going to commit the file. We're going to update demo.py, changing the variable b, demo purposes. So we've now committed that change. We can check git status. We no longer have the demo.py because it's committed to our local repository now. Now we can push that change. So we use git push. We specify our remote, which we call origin. And then we're also going to specify the change, the branch. Use here. Great. So now we can refresh this and we should have a new branch. Oh, great. So we had recent pushes to this new branch that we created. So now if we try to compare and pull request, great, this is the same as before. So now you'll see that it requires review because of how we implemented our new rule. So normally if you had people working on it with you, you could request their review and then they can review the change. They can go through, they can look at files change, they can see if this change makes sense. They can identify any problems. It's also quite nice, very collaborative. You can make comments in GitHub. You can be like, change this or fix this. So if your review is requested, you can go through and you can add comments for the changes that you'd like to request someone to make before they can merge, and then they'll like update their pull request. There might be a couple rounds of iteration on this. You can request other people's reviews. So perhaps like you're not the most familiar with something, so you might ask someone else to help take a look at it also. And essentially after people have reviewed it, they approve, and then only after that can you merge into your main branch. And this is really nice because it like forcibly requires you to collaborate essentially, and also it creates like a safety check before you potentially break your main branch. Yeah, so that's essentially we set up a remote repository posted on GitHub. We've talked through how to protect your main branch using GitHub's features, how code review works roughly. And then GitHub best practices, like I mentioned, you generally want to try to protect your branches. You want to be very careful, like very good about how you write commit messages, how you have your PR descriptions also, your pull request descriptions, very succinctly describe the changes that you made. This helps reviewers to understand what is different, what changes you've committed in your pull request. And that's pretty much all I have. Right, we reviewed Git as version control, and then we also set it up as a remote repository. And that's all I have for my talk. Thank you all very much for staying on.
Thank you, Julie, for the fantastic presentation and for covering these different software engineering fundamentals that we see across all of the research projects. So thank you.